Hey, good morning, AP students. We're going to be talking about AP topics 5.8, 5.16, and 8.5. I'll share these slides with you, but please follow along here and make sure you're taking notes. So the first one here, 8.5, is the impacts of overfishing. So when humans use natural resources, they alter natural systems. We know that from a lot of the different things we've looked at this entire year. But overfishing particularly has led to extreme scarcity of some fish species, which has a problem of lower biodiversity, and it also can harm people who are specifically relying upon these species for food and income. Okay, so some people maybe are using this as a way of income, some people this is their food source. Okay, so it does have some negative consequences. Here's some examples. There we go. You can see here on the left, in overfishing this Atlantic cod, you have a really big increase, but you have like a pretty high number right here, and then this really big drop after that. So people overfished, and eventually 1992 they didn't have any more of this Atlantic cod. I mean, you have a little bit of a resurgence right here. You can still get it, but it's mostly grown in like fish farms, not naturally. Okay, but this is, I guess, specifically in Newfoundland, which is part of Canada. Okay, another example of where it's worked well, lobster in the Northeast, they had kind of these informal agreements to say, hey, we're not going to catch them if they're not a certain size, and also if it is a female, and that is going to give us more lobster in the future, they don't catch those ones. Okay, so this is an example of where rather than overfishing, they kind of got together and said, hey, let's not have that happen. That all is an example of the tragedy of the commons. We've talked about that in the past, but just a reminder, you should know that concept. Tragedy of the commons, basically there's a common space, no one really manages it, so if nobody's managing it, we could overuse it, but sometimes people do get together and manage this themselves, like right here with the lobster. Okay, this brings us to 5.16, aquaculture. So Jamon proposed to us this aquaculture plan, and we need to know that humans can mitigate their impact on land and water through sustainable use. So aquaculture is one example. Specifically, it's farming aquatic organisms in controlled conditions. You can see some examples here around the United States. So we have Atlantic salmon that's being grown, okay? We have tilapia, we have more salmon down here, indoor tanks, catfish, seaweed, and then oysters as well. So here's some examples of aquaculture. You can see visually here, they have these tanks where they're growing, or nets rather maybe, where they're growing fish probably, and then they can get around here and then harvest them. So some benefits of aquaculture. One, it's efficient. It uses a small amount of water, and then it requires little fuel unless you're really going to be using these offshore options way out here. But all these ones that are close, they're able to fish without needing to go way out into the ocean. Okay, they're able to get the fish much more quickly. And then there is the benefit as well of less space being used, and it's pretty efficient to grow things. So you can see here that they have examples in this image of different positive things. So we could have like this one that's offshore, that's not really going to be impacting the seafloor or the fishing communities. You want to put them in fast current spaces so that the materials they use and produce kind of go away quickly, so you see the current here. And then also seaweed farming is an option to actually be good for the environment and estuaries because it's going to clean up the water. One thing to know is it can impact fishing areas, and we are a fishing community, so keep that in mind. Keep moving here. Some drawbacks of aquaculture. You could pause and read this whole visual or look at it on the slides, but the organisms being farmed can contaminate the water. We're going to talk more about this big word here, eutrophication, in the next slide, but that is a problem. Fish can escape and then compete or breed with the wild fish, and then overall the density of fish in aquaculture can lead to increases in disease. So you see here, obviously a net is a permeable surface, so things can get out. Not much is going to get in, but things can get out, which can be a problem. We're also going to need to use like the fish meal. We're going to need to use possibly antibiotics or herbicides, things like that. So these obviously aren't going to stay in this space. It's going to get into the ocean, which could be a problem. Okay, and then finally, eutrophication. Human activities, including the use of resources, have physical, chemical, and biological consequences, and eutrophication is no exception. This is the enrichment of water with nutrients. We talked about this with farming, but you get nitrogen and phosphorus that gets into the water, and this leads to excessive plant. Sorry, too many ands here. Excessive plant and algae growth, because plants and algae are producers. We know they need nitrogen and phosphorus so that when it gets in the water, it could cause these big blooms. So kind of the steps here. You get the nitrogen, phosphorus added, you get these blooms of algae that form, and then what happens is eventually they're going to die. So once they die, they decay, and the bacteria here that is going to eat this, the bacteria that eats this stuff, is going to take in a whole bunch of oxygen. Our producers give us the oxygen, but then the bacteria will eat the oxygen, which creates dead zones. So finally here are some dead zones. We have the algae bloom, it dies, and then we get a dead zone. There's not a lot of oxygen here. And if we don't have oxygen, the animals can't survive. The other things that live there can't survive. And I have a visual here for you. This is the Mississippi River coming down. The Mississippi River is going to be catching a lot of runoff from all these farms, from Illinois, Iowa, all the way down. All that gets carried in this river and makes its way to the Gulf of Mexico. This is the Gulf of Mexico. Can't even see that. The Gulf of Mexico. And then the problem is all that nitrogen, all that phosphorus can cause these big algae blooms in the springtime. After the algae blooms, then it's going to die. And when it dies, the bacteria will eat it, and we get these big dead zones. So that's a big problem, okay? That connects back to our aquaculture, because the things that we're going to put in to help our fish to grow is not going to obviously stay in that one spot. I'm realizing I wrote the Gulf of Nitrogen, not the Gulf of Nitrogen. Here I am like someone trying to rename the Gulf of Mexico. Okay, so there you have it. Make sure you've taken some notes on this.